Hello and welcome to the Virtual Machine High Availability screencast. In this screencast, we will walk through the process of setting up Virtual Machine High Availability and verify that the virtual machine is going to be migrated to another host when the initial host is going to be powered down. Virtual Machine High Availability is a powerful feature with a lot of fine-tuning. However, one of the major requirements is the shared storage. Without shared storage, Virtual Machine can only be respawned on a different host, but will lose all of the data. That can be suitable for stateless virtual machines when the data is not a concern, but the true virtual machine high availability is only available in an environment with a shared storage. Virtual machine high availability relies on the hook subsystem. The hook subsystem is a powerful automation and integration functionality that is available in OpenNebula. This functionality allows the execution of any script based on the virtual machine, host, or image state change or API call. To learn more about the hooks functionality, please visit the official OpenNebula documentation. Fencing is important to prevent the split brain issues. You must edit the following script: var lib1 remotes hooks ft fence_host.sh and supply it with the correct fencing command. The environment for this demonstration consists of one host with the OpenNebula front-end software, two KVM hosts managed by OpenNebula. Each host has a virtual machine running, shared storage that exposes system and image data stores and is mounted to each node, including the front end, using the NFS protocol. To enable the VMHA, we must configure the hook first. You can find the hook template in the official OpenNebula documentation. There are additional flags that can be passed to the script in some scenarios. Each of them also is described in the documentation. To create a hook, we're going to create a file and we'll paste the hook template contents. The default hook settings are very cautious, which may lead to longer virtual machine migration time. However, they are less error prone. In the scope of this demonstration, we're going to make it much more aggressive. Additionally, there is no need to fence the host because I'm going to power it down myself. Hence, the no fencing flag has been added. Please note that the no fencing flag works in the demo environment, but should never be used in a production environment. The hook will execute the host_error.rb script if any host changes its state to error. Save the file and then use the OneHook create command line tool and point to the file template. Now the hook has been created successfully. You can inspect the hook contents as well as list all the hooks using the same OneHook command. In your production environment, you should additionally configure the fencing mechanism. Once again, you should not run virtual machine high availability without fencing in the production environment, so please take care of this first. Let's switch to OpenNebula Sunstone. We have virtual machines running on two different hosts. Let's open the VNC session to one of the virtual machines and log in using the configured credentials. Once logged in, let's start pinging the second virtual machine that's located on another host that will be powered off. We're going to use the ping command to capture the moment when the virtual machine went down along with the host and when it successfully started on another host. Switch back to the command line interface, this time to the KVM node, the one that will be powered down. Execute the shutdown command. Now let's observe the state change of a host using the OpenNebula command line oneHostTop. As seen on the screen, the host state just switched from on to error. By switching to the Sunstone Web UI, we can see that the pings were indeed interrupted for a while, but the virtual machine was brought back to life shortly. Please note that the downtime can be brought down by fine-tuning the hook and OpenNebula's built-in monitoring system. You can observe the execution log in var log1 host_error.log file. Additionally, we can confirm that both virtual machines are now running on the same host. That is the result of a virtual machine high availability hook execution. And this concludes our screencast, where we have shown how to enable and test the virtual machine high availability feature of OpenNebula. Thank you for watching and see you in the next screencast.